Hi everyone, it's Mrs. McInnes here. Welcome to lesson 1 of our new topic, which is the second half of quadratics. So in the first topic of quadratics, we looked at sketching out parabolas and various questions related to the sketches. But in this part of quadratics, we are purely looking at the algebra side of the topic. So the first thing I'm going to talk to you a wee bit about is solving quadratics graphically. So we've actually kind of looked at this when we did sketching out the graphs. This is the same idea as just finding your two roots. So there's a few points to go through in the written section of your notes here. So let's go through this first. So we have here some notes about quadratics. We've got here at the top that solving a linear equation, so something like a straight line equation where there's only one x term, gives you just one solution. So for example, if your straight line equation was y equals 2x plus 3, there would only be one solution to that for x, so it would be x equals and one answer. That's because there's only one point where that line would cross the x-axis. But for quadratic equations, where there's an x squared term, we will get two solutions. So a quadratic, you'll remember this from when we did sketching, is in the form ax squared plus bx plus c equals 0. So it's got to be an equation with an x squared term in it. If we are solving quadratics, you must have the right-hand side of your equation as 0. So it has to be something x squared plus something equals 0. If it's not, you need to rearrange your equation first of all, and we will get to that when we go through some examples today. So like I've said, the solutions to a quadratic equation are the same thing as finding the roots. So when we did sketching and the piece of working we did for finding your two roots, that's the same piece of working that we would do for finding your solutions. It is where the graph cuts the x-axis that we're looking for as your roots of the graph or your solutions. So there's a little example here of graphically that I'll just quickly talk through, and then we'll get on with the algebra examples. So here you have a graph showing y equals x squared minus 3x. So if we look for the two roots, then we can just write down our solutions. So you can see here from this sketch that you have the graph crossing the x-axis at 0 and at 3. So the solutions to this quadratic would be x equals 0 and x equals 3. That's the 2 points where that graph is crossing the x-axis. So rather than having to draw out your graphs every time to find your solutions, we can just find our solutions with algebra, using our algebra skills, so purely by factorising, and that's what we're going to be looking at just now. So the most common way to solve a quadratic is just to use your algebra skills. So what we're going to do here is we're going to use the fact that we know when we multiply two things together and get 0, that one of those two things had to be 0. Okay, so something multiplied by 0 will always give you an answer of 0. So if we put that into context of what we're looking at here, if we factorise our quadratic, say, into double brackets, and we know that it's equal to 0, that means that either the first bracket, so in this example here, we've got x minus 2 and x minus 3. So either that first bracket, x minus 2, has to be 0, or the second bracket, x minus 3, has to be 0. We take both of those eventualities as our solutions. So the first bracket, if x minus 2 is equal to 0, then x would be 2. And if the second bracket, x minus 3, is equal to 0, then x had to be 3 in that bracket to get a 0. So our two answers there would be x equals 2 or x equals 3, and we just write both solutions. So if we go into some examples of this, this will be a recap for you as well of your factorising skills, but really at this stage in the course, I would expect you to be able to factorise without very much difficulty. Possibly some of my later examples in this video, you might find those factorising questions a wee bit tricky, but the first maybe 2/3 you should be able to do fairly confidently, okay? So the first example here, we've got A, B and C. These have already been factorised for you. So I'm going to go straight into solving. So this first one we have x bracket x plus 1 equals 0. So in this case, to get 0 as an answer, either the x on the outside has to be equal to 0 or the bracket x plus 1 has to be equal to 0, so that when we multiply those together, we get 0 as an answer. So either of those has to be 0, so we just look at both. So your first one, x equals 0, that's already solved. The second one, x plus 1 equals 0, all we do here is a wee bit of balancing equations. So we would take away 1 from both sides and we would get x equals minus 1. So your two answers here would be x equals 0, x equals minus 1. So I'm just going to write those both at the bottom. Your second example here, we've got x minus 5 bracket x plus 3 equals 0. So either that first bracket, x minus 5, has to be 0, or the second bracket, x plus 3, has to be 0. So we're going to go ahead and solve both of these equations. So for that first one, we would add 5 to both sides. So we would get x equals 5. And the second one, we would take away 3 from both sides. So x equals minus 3. So at the bottom, I'm just going to write these both. X equals 5, x equals minus 3. The last example here, again, is double brackets. So we have 2x plus 5 bracket 3 minus x equals 0. So either the first bracket, 2x plus 5, is a 0, or that second bracket, 3 minus x equals 0. So let's solve each of these. So we would take away 5 from both sides first for this one. So we get 2x equals minus 5, and then we would divide both sides by 2. So x equals minus 5 over 2. I would leave these as fractions. I wouldn't bother with putting them into decimals. This second one here, we've got 3 minus x equals 0. So we would subtract 3 from both sides. That is going to give us minus x equals minus 3. And then because they're both a negative, we would change them both to positive, so x equals 3. So for this last one, our two answers are minus 5 over 2 and x equals 3. So these three examples were already factorised, and here we have how we go through writing out the solutions for each question. Let's move on now to where we need to factorise first of all. So if the equation is not already factorised, you will need to do a few things first of all before you solve. So in the box at the top here, we have your steps. So the first thing you need to do is check that the right hand side says equals 0. If it doesn't, you'll need to rearrange your equation so that it does say equals 0. Then we're going to factorise the left hand side and then solve for each bracket like I did in the last example. So for example 2, we have quite a lot of different examples to go through, which will cover a range of different factorising styles of questions. So you'll get a good recap here of all your factorising skills as well. So for example A, we have x squared plus 11x equals 0. So if you remember, when we do factorising, we always look first of all for our highest common factor. If there is one, you take that out. Whatever's in the bracket, you then look and see if that is a difference of two squares. So do we have two square terms with a subtract in between? And if you do, then you would solve that. If you don't, you check to see if you have a trinomial. So a trinomial is your squared term and then a letter term and then a number term. So going through the steps, the first thing here we'd look for is a common factor. So x squared plus 11x equals 0. We have an equal 0 on the right hand side, so we can just go right into factorising. So here we have a common factor of x. So we would take that out first of all. So that gives us x bracket x plus 11 equals 0. So now we can solve this. So either this x on the outside would be 0 or the bracket x plus 11 equals 0. So to solve this second one, we would just take away 11 both sides. So x equals minus 11. So we have 0 and minus 11. For B, we have 3x minus 6x squared equals 0. So we have equals 0 on the right hand side. We can go right into factorising. First thing we look for is a common factor. So these both divide by 3x. So 3x is your common factor, and then inside your bracket you're going to have 1 minus 2x. So either 3x equals 0 or 1 minus 2x equals 0. So if 3x equals 0, then x would simply be 0. Dividing both sides by 3, we still get 0. For the second one, we would get minus 2x equals minus 1, because we would take away that 1 from both sides. Then we would change these both to positive, so 2x equals 1, and then divide by 2, so 1 over 2. So our solutions here are x equals 0 and x equals a half. Our next two examples here, we have x squared minus 9 equals 0. So first thing we do is check for common factor. So there is nothing we can divide x squared and minus 9 both by. Then we look and see, is this a difference of two squares? X squared is a square term, 9 is a square number, so this is a difference of two squares. So this goes into double brackets. For x squared, it will be an x, and then one bracket is plus, one bracket is minus, doesn't matter which way round. And then for 9, we would square 3. 3 squared gives you 9, so it's a 3 and a 3. So your first one here, we've got x plus 3 equals 0, and we've got x minus 3 equals 0. So the first solution, we would get x equals minus 3. Second one, we would get x equals 3. D, we have 64 minus x squared equals 0. So there's no common factor here, but we do have two square terms with a minus in between. So it's another difference of two squares. So for 64, we would do 8 squared. So it's 8 and 8 in each bracket. We do 1 plus and 1 minus. And then for x squared, it's x and x. So our first one, we have 8 plus x equals 0. Second solution, we have 8 minus x equals 0. So 8 plus x equals 0, we would get x equals minus 8 for that solution, because we'd take away 8 from both sides. On the other side, we would get minus x equals minus 8, because we would also take that 8 away from both sides, but then these would both turn to positive because it's a minus and a minus. So we'd get x equals 8. So our two solutions are minus 8 and 8. Okay, stepping up the factorising to be a little bit more complicated. For E, we now have 2x squared minus 72 equals 0. So we always look first for common factor, and these terms both divide by 2. So 2 would be our common factor, which would leave us with x squared minus 36 in the bracket equals 0. Now inside that bracket, we have a difference of two squares. They're both square terms. So we're going to have double brackets. So here we have two steps of factorising to do. So an x and an x for the x squared, 1 plus, 1 minus, and then to get 36, we would square 6. Now in this case, it's only inside the brackets that we use for our solution, so you don't need to worry about the 2 at the minute. So we've got x plus 6 equals 0 for our first solution, and x minus 6 equals 0 for our second solution. So the first one, we would take away 6 from both sides, so we get x equals minus 6. The second one, we would add 6 to both sides, so we would get x equals a 6. So your two solutions are x equals minus 6 and x equals 6. Okay, for F, we now have a different kind of factorising. We have x squared plus 6x plus 5 equals 0. So there's no common factor. It's not two square terms with a subtract in the middle. So we'd be thinking it's a trinomial. We have a square term, a letter term, and a number term. So that is a trinomial. So here we would be looking to put this into double brackets. And this is a very simple one, so I would think you could just do this in your head very quickly. We're looking for an x and an x in each bracket to get our x squared. We're then looking for the numbers that multiply to 5 but add up to 6. Well, that's going to be a 5 and a 1. Both of these signs inside this trinomial are positive, so it's just going to be plus 5 and plus 1. So it's a very simple trinomial to solve. So your first bracket gives you x plus 5 equals 0. so x would be equal to minus 5. And then your second bracket gives you x plus 1 equals 0, so x equals minus 1. So your two solutions here are minus 5 and minus 1. Okay, so now moving up again in difficulty with the factorising, we have some more trinomials to do, but these will be a little bit more tricky to solve, so we'll go through these now. So for g, we have x squared plus 3x minus 40 equals 0. So we should be able to recognise that as a trinomial straight away, so we know this is going to go into double brackets. So minus 40, we need two numbers that multiply to minus 40, but add up to positive 3. So for minus 40, what is useful to do is write out a list of the numbers that you can multiply to get minus 40. So we could have minus 1 and 40, or 1 and minus 40. We could have minus 2 and 20, or 2 and minus 20. We could have minus 4 and 10, or 4 minus 10. And we could also have minus 5 and 8, or 5 and minus 8. So if we look through that list, we're looking for the pair of numbers that would add up to give us positive 3. So that's going to be the minus 5 and the 8. Minus 5 add 8 gives you positive 3. So that's the two numbers we would use in the brackets. So we're going to have x minus 5 and x plus 8. So when we do our two solutions, we've got x minus 5 equals 0. So x would be equal to 5. And we've got x plus 8 equals 0. So x would be equal to minus 8. So your two solutions here are 5 and minus 8. Okay, for h, we have 3x squared plus 11x minus 4 equals 0. So this is probably the most complicated type of trinomial you will have to factorise. So I'm going to show you here the method that I would use to solve this, and if this works for you, great. If it doesn't, you can do any method that works best for you. So what I would tell you to do here is, because this is not a single x squared, it's 3x squared. The method I did just on the left hand side here, we need to adapt that slightly to take into account that extra 3 as a coefficient for the x squared. So if we take that 3 and the end number minus 4, that is what we're looking for as numbers to multiply to that answer. So if we do 3 times minus 4, we get minus 12. That's what we would do a list of the factors of minus 12, of the pairs of numbers that multiply to minus 12. So we could have minus 1 and 12, 1 and minus 12, minus 2 and 6, or 2 and minus 6, and minus 3 and 4, or 3 and minus 4. So now we are looking for the pair of numbers that is going to give us plus 11. So for plus 11, that would be minus 1 and 12. Minus 1 and 12 would give us 11. So what I'm going to do is I'm going to write 11x as minus x plus 12x. Okay, so I'm going to use that minus 1 and plus 12 to rewrite that middle term. Okay, the first and last terms are going to stay as they are. Then what I'm going to do is factorise the first two terms and factorise the second two terms. And this is what's going to give me my double brackets. So 3x squared minus x, well, the factor there would be an x. And then in the bracket, I would have 3x minus 1. And then for 12x minus 4, they both divide by 4. So that's my factor. So it's 4 bracket 3x minus 1. What you'll notice here is that both of these brackets are exactly the same. 3x minus 1, 3x minus 1. You are looking for that to happen so that you can form your two brackets, okay? So the two terms outside give me my first bracket. So that gives me x plus 4. And then I've got this 3x minus 1 bracket twice, so that gives me my second bracket. Okay, this process is basically the reverse process of FOIL. Okay, because when we break this bracket out, we would do x times 3x and minus 1, which is the first part of that working. And then we do 4 times 3x minus 1, which is the second part. So it's basically just FOIL in reverse. Now that we have this into double brackets, we can go ahead and solve. So we've got x plus 4 equals 0. So x equals minus 4. And then we've got 3x minus 1 equals 0. So 3x equals 1. X equals 1 divided by 3, so 1/3. So my two answers here are x equals minus 4, x equals 1/3. Okay, a few more examples to do here now. For example, there is a mistake in the notes. That should not be 6, it should be 5 at the beginning of that. If it was a 6, it wouldn't be factorised, so it should be a 5. So here, this is a trinomial, but it's laid out backwards. Okay, so that makes things a little bit more tricky. But if you use the method I just showed you a minute ago, it's not actually any harder than the previous example. It's just laid out backwards. So we're going to take the first number and the coefficient of that last number. Because it's just the other way around, it's still those two numbers that we're going to multiply. So it's the minus 6 and the 5. So minus 6 times 5 gives us minus 30. That's what we're going to do a list of numbers for. So we could have minus 1 and 30, 1 and minus 30. We could have minus 2 and 15, or 2 and minus 15. We could have minus 3 and 10, 3 and minus 10. And that's all of our list. So now we're looking for the numbers that are going to give us minus 13 in the middle. So to get minus 13, it would be 2 and minus 15. So we're going to rewrite that middle term, minus 13x, as plus 2x minus 15x. And then the first and last terms are going to stay as they are. We're then going to factorise the first two terms and the last two terms. So 5 plus 2x, there is no common factor really there. There's nothing that they both divide by. So your common factor there is actually just 1. They both divide by 1. So it's 1 bracket 5 plus 2x. And then you've got minus 15x and minus 6x squared. So they both divide by minus 3x as your common factor. And then inside your bracket, you would have 5 and plus 2x. So here again, you can see that the two brackets are the same, 5 plus 2x for both, and that is what you need for this to work. So the 1 minus 3x gives me my first bracket, and then the 5 plus 2x gives me my second bracket. Now we can go ahead and solve. So 1 minus 3x equals 0. So taking away 1 from both sides, we'd get minus 3x equals minus 1. So that means that 3x equals 1, and then x equals 1 divided by 3, so 1/3. And then your second bracket, we've got 5 plus 2x equals 0. So 2x equals minus 5, x equals minus 5 over 2. I'm not going to write those both at the bottom just because I'm going to run out of space, but that would be your two solutions just at the bottom there. Okay, just a few more examples to go through here. So, next one here, we've got 5x minus 2x squared minus 3 equals 0. So this is not laid out in the right order. It should always be your squared term first, then your letter, then your number. What I would do with this is actually, because we have minus 2x squared, to make that easier to solve, I'm going to try and turn that positive. And the way to do that would be to multiply the whole equation by minus 1. That will change the sign of each term. So we'd get minus 5x plus 2x squared, and then plus 3 equals 0. And then all we need to do is just rearrange that around into the right order. So 2x squared minus 5x plus 3 equals 0. So again, because this is not a single x squared, I'm going to use that method of multiplying the first and last terms. So 2 times 3 gives you 6. So we're looking for the numbers that multiply to 6, but because you have a minus 5 as your middle term, you have to think of your negatives as well. So we could have 1 and 6, or we could have minus 1 and minus 6, or 2 and 3, or minus 2 and minus 3. So to get minus 5, it's going to be minus 2 and minus 3. So we would write that out as 2x squared minus 2x minus 3x for that middle term instead of minus 5x plus 3 equals 0. Now we're going to factorise the first 2 terms and the last 2 terms. So your first term, you've got 2x squared minus 2x. Well, they both have a common factor of 2x. So it'll be x minus 1. And then your second bracket, you have minus 3x plus 3. So they both divide by a minus 3. And that will give you x minus 1 in the bracket. You can use the fact that you know the bracket is supposed to be the same as the first one to help with finding that factor. Is it 3 or is it minus 3? So that gives us 2x minus 3 for our first bracket and then x minus 1 for our second bracket. So solving this, we now get 2x minus 3 equals 0. So 2x equals 3. X equals 3 divided by 2. And the second one, we get x minus 1 equals 0, so x equals 1. Okay, on to our final 2 examples here, where we just need to do some rearranging before we solve. So over here for k, we have x squared plus 5x equals 14. Remember, way back at the beginning of the video, I said it has to say equals 0 before you factorise. So all we need to do here is just bring that 14 across. Take away 14 from both sides. That will make that then say equals 0. So for minus 14, we're looking for our numbers that multiply to minus 14 but add to 5. So it could be minus 1 and 14, 1 and minus 14. And it could be minus 2 and 7 or 2 and minus 7. So to get our 5 in the middle, it's going to be minus 2 add 7. So because this is a single x squared, we can just go straight into the double bracket. So x minus 2 and x plus 7. We only need to do that method I was doing in the last few examples if it's not a single x squared, if it's 2x squared or 3x squared or so on. So our 2 answers here, we've got x minus 2 equals 0, so x equals 2. And we've got x plus 7 equals 0, so x equals minus 7. Our final example here, we have our double brackets and then equals 6. So everything has to be on the left-hand side. So what we're going to have to do here is use FOIL to remove the brackets and then bring that 6 across to the left so that it says equals 0. So if we break out the brackets with FOIL, we've got x squared minus 2x plus 3x minus 6 equals 6. And then if we tidy this up, we've got x squared minus 2x plus 3x is plus x. We've then got minus 6, and then we're going to bring the 6 on the end across, and that will be minus 6 as well, so that it's equals 0. We're taking 6 off both sides. So that will tidy up to x squared plus x minus 12 equals 0. So for minus 12, could be 1 and minus 12, minus 1 and 12, 2 and minus 6, minus 2 and 6, or 3 and minus 4, or minus 3 and 4. So to find the pair that give us a plus 1x plus 1, it's going to be minus 3 and 4. Minus 3 add 4 gives you 1. So in your brackets, you're going to have x minus 3 and x plus 4 equals 0. So 2 solutions will be x minus 3 equals 0, so x equals 3. Or x plus 4 equals 0, so x equals minus 4. So I know that is a lot of examples, but that is covering every kind of factorising that you could possibly get asked. I'm not going to give you a lot of questions to do on this today. I'm just going to give you from the Unit 5 booklet, which will be, if you go into the Files section, Unit 5 class booklet, that's saved in there. So the Unit 5 booklet, page 5, question 2 to 5, but I only want you to do 4 from each one of those. So A, D, G and J. It's the first 4 down in the first column. So question 2, 3, 4 and 5, 4 from each one. So I'm not going to give you a whole lot of these to do because I know this is quite a long video. Okay, if you need any help, please come on and ask me for it in the call or on the Teams page. And as usual, mark your work from the back and then email me a picture when you are finished.